Good morning, students. This here is a lesson that I have for you on how to do average atomic mass questions. And I brought out some of the more difficult questions, and I'm going to show you a step-by-step guide for how to solve them. The very first thing that I want to go over here before we even look at a question is going to be the fact that an average atomic mass is always going to have the same type pattern. So an average atomic mass problem is always going to have a isotope that we have right here. So we're always going to have an isotope, and that's going to have some certain mass. Then we're always going to have some sort of percent that's associated to it, and then we're going to go ahead and do it again. So what's always going to happen is that we'll always have usually more than one isotope, and its mass is going to go in right here. So this will be isotope 1, and then this could be isotope 2. And the mass of 1 times its percent plus the mass of the second one times its percent will go ahead and give us what we're looking for, which is our average atomic mass. So we're going to be looking for A, and then N. All right, and that's going to be how every single one of these problems is going to go. All right, so we're going to go ahead and get a new one here. And we're going to look at this first question here. And this first question is giving us a graph. Okay, and with this graph, it's asking us to determine the average atomic mass for iridium. And when we have the average atomic mass, we're going to notice here that first we have two big peaks here. We see that we have 193 and 191. So these are our different masses. And then we see that we have two numbers here, and these numbers represent how many we had. Okay, so to start with, what we have to do is we have to go ahead and we're going to write down what our formula is. And our formula is always going to be the mass of the first one times its percent abundance plus the mass of the second one times its percent abundance. Okay, and that's always going to give us our average atomic mass. So let's go back to this one here, and we're going to see that we have a mass of 191 and a mass of 193. So that means that we could fill in both of our masses. But in this case, it does not give us the percentage, okay? Which means that we're going to have to find the percentage based off of the number of hits. And we should note that we have more hits for 193. It says that we had 100 hits. And that for 191, it said we had 59.49, okay? So we're going to go back to our main sheet here, and with our main sheet, we're going to go ahead and put the first one as its mass being 191, and the second one we have a mass of 193. Then we're going to go ahead and take note, and we knew that we had 59.49 hits from the first one, 100 hits from the second one, for a total number of 159.49 hits. Okay? Since we know our total, we can then figure out our percent. So this first one, to figure out our percent, we're going to go ahead and take 59.49 and we're going to divide that by 159.49. So 159.49, and then we have 59.49, and that's divided by that one, okay? So we take this one divided by this one, and it's going to give us our percent. And in this particular case, our percent ends up being 0.373. This one right here was the larger one. This one was 100, so we had 100 hits. So this time, we're going to figure out our percent by taking 100 hits And we're going to divide that one by 159.49. And in this case, our percentage ends up being 0.627. Okay. And once we have this figured out, we just have to go ahead and FOIL this through. So we have to go ahead and multiply this through. 191 times 0.373 is going to give us a number of 71.243. And this is the mass that's coming from the 191. The mass that's going to come from the 193 ends up being 192. Or sorry, my mistake. That's 121.04. And then we would just have to add these two numbers together. Okay, so we take this 71.243 times 121.04, and that'll give us a total of 192.254. Okay, and this is our average atomic mass and our answer. Okay, now we're also going to go ahead and take a look to make sure that our answer makes sense. Our two isotopes that we had for 191, 193, our answer should be between them. Also, we should notice that we had more of 193. Our answer should be closer to 193. And in this case, our answer of 192.254 is where we would expect it to be. It's closer to 193, and it's between those two numbers. Now, we're going to get into the harder type of problem here. And this is a problem where we're going to have to use a little bit of algebra to solve it. In this case, we have chlorine. It tells us that it's an element and it has two different isotopes. Okay? And it tells us the average atomic mass. Okay? And it wants us to determine the percent composition of chlorine 35. So we have to determine the percent. Okay? So we're going to go ahead and we're going to get a new sheet. And we know right away that our formula is always going to be mass of one isotope times percent plus the mass of the second isotope times its percent. Okay, and we already know the two masses. We know we have chlorine 35 and we have chlorine 37. What it's asking us to solve is this percent right here, and we don't know what this percent is. So we're going to go ahead and put it as X. Here, we also don't know what this percent is. However, since we know that the total of both of these samples is 100% of our sample, and we know that because it says that it's only composed of these two elements, these two isotopes, we can go ahead and say, hey, this one plus this one has to equal 100%. So therefore, we could put 1 for 100 minus X. Okay? And that's what this percent is going to be. Okay? After we do that, we could figure out average atomic mass. And in this case, it gives us the average atomic mass. And that's 35.45. And now what we have is we simply have an algebra problem that we have to solve. In this case, we are just solving for X. So we're going to go ahead and just multiply through. We're going to go ahead and multiply 35 times X. And then we're going to take a look here. We have 37 times 1 is 37 minus 37X. And all of that is going to equal 35.45. Now at this point, we can go ahead and take like terms and we're going to go ahead and combine them. Okay, So we're going to take these x's, we're going to combine them together. 35x minus 37 equals negative 2x. And then we're going to see that we have 37 over here, and we have 35.45 over here. We're going to subtract that from both sides. So we're going to subtract 37 from here and 37 from here, and we're going to get 1.55, and that's going to be a negative 1.55. We're going to divide negative 2 from both sides now. Okay, so we're going to divide by negative 2. And that's going to tell us that x equals 0.775 or 77.5%. And we can go ahead and check this answer and see if it makes sense. Our average atomic mass was 35.45%, which means that it should be a greater percentage should be 35. And this right here says that our percentage is 77, which makes sense for our answer. That's going to go ahead and close out the questions for today. Hopefully this was able to help.